Hi guys, so today we're going to continue the discussion on differentiation of vector valid functions. Okay, another definition. The parametrization of the curve represented by the vector valid function r of t equals f of ti plus g of tj plus h of tk is smooth on an open interval I when f prime, g prime, and h prime are continuous on interval I and r prime of t is not equal to 0 for any value of t in the interval I. Okay, so as an example, we need to find the intervals on which the epicycloid C given by this equation, r of t is 5 cosine t minus cosine 5t times I plus 5 sine t minus sine 5t times j, where t is from 0 to 2 pi is smooth. So to find intervals on which this epicycloid C is smooth from this interval, so we need to find the first derivative of this vector valid function. Okay, the first derivative of r of t is r prime of t, and derivative of cosine t is negative sine t times 5. So you have negative 5 sine t, okay, minus the derivative of cosine 5t is negative sine t times 5, but negative negative is positive. So you have positive sine 5t times I. Plus, the derivative of sine t is cosine t times 5. So we have 5 cosine t minus derivative of sine is cosine 5t times derivative of 5t is 5, 5 times cosine of 5t times j. So, in this given interval na from 0 to 2 pi, we have to find those values of t that satisfies this vector valid function r prime of t, which is equal to 0i plus 0j. So, as by observing the value of the interval, we can observe that this ith component and j component are both equal to 0 if the value of t is 0. So by substitution, if t is 0, you have sine 0 is 0, and 5 times 0 is 0, and sine 0 is 0. So this is 0i. Plus, in this case, if t is 0, cosine 0 is 1, so you have 5 minus cosine of 5 times 0, this is 0, and cosine 0 is 1 times 5. So you have negative 5. But 5 plus negative 5, so that's 0, so you have 0j. Okay, same thing when t is equal to pi over 2. This becomes sine of pi over 2 or 90 degrees is 1 times negative 5, so negative 5. This is also equal to 5 times t, where t is pi over 2, so you have 5 pi over 2. This is sine of, because this is 1 complete rotation plus pi over 2. So sine of 5 times pi over 2 is also the same as sine of pi over 2. But recall that sine of pi over 2 or 90 degrees is 1 times 5 is 5 plus negative 5. So you have 0i. Here, if t is pi over 2, cosine of pi over 2 is 0 times 5 is 0. Next, 5 cosine of 5 times t, where t is pi over 2 is 5 pi over 2. And cosine of 5 pi over 2 is 0 times negative 5 is 0 plus 0. So you have 0j. Okay, so as you can see, the interval on which r prime of t is equal to 0i plus 0j are those values of t within this interval that are multiples of pi, including 0. So you have 0, pi, 2 pi, and then multiples of pi over 2, such as pi over 2 and 3 pi over 2. So we can say here that this vector valid function is not smooth on this values of t. When t is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So therefore, you can conclude that the curve C is smooth on this interval na from 0 to pi over 2, pi over 2 to pi to 3 pi over 2, and 3 pi over 2 to 2 pi, no, as shown in this figure. So there is a cast at t is equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. In the previous figure, no, we can note that the curve is not smooth at points at which the curve makes abrupt changes in direction. So such points are called caps or nodes. Okay, next we go to the properties of the derivative. So according to this theorem 12.2, so let R and U be differentiable vector valued functions of t, and let W be a differentiable real valued function of t, and let C be a scalar. Okay, that number one, the derivative of C times R of t with respect to t is equal to C because C is constant, so you can factor this out, and then take the derivative of R of t, which is R prime of t. And then the number two, the derivative of the sum or difference of two vector valued function R of t and U of t is also the same as the derivative of the first vector valued function denoted by R prime of t plus or minus the derivative of the second vector valued function U prime of t. Okay, number three, the derivative with respect to t of the product of W of t and R of t is also the same thing as the first vector valued function W of t times the first derivative of R prime of R of t plus the first derivative of W of t times R of t. So you have to use the product formula. First derivative of the second plus the second derivative of the first. Okay, number four, the derivative of the dot product of the two vector valued function R of t and U of t is equal to R of t that with the first derivative of U of t plus the first derivative of R of t that with the vector valued function U of t. The number five, the derivative of the cross product of the vector valued function R of t and U of t is equal to the cross product of the first vector valued function R of t and the first derivative of the second vector valued function U of t. Okay, plus the derivative of R of t cross with the vector valued function U of t. Okay, number six, the derivative of the product of R and R of W of t is equal to R prime of W of t times the derivative of W of t. And then lastly, number seven, if the dot product of R of t and R of t is equal to C, then we can say that the dot product of R of t and R of t is equal to 0.